Hello, dear aspirants. This is Dr. Sourav sir's class. We are now solving our National Boards of Higher Mathematics linear algebra problem from our year 2020-2014. So, the question tells us that let B be a real symmetric non-negative definite. Yeah. So that means non-negative definite is our determinant of A is greater than equals to 0, non-negative definite. So 2 cross 2 matrix and such that our B square is equals to A. So where our A is 5 minus 3 minus 3 5. So we have to write down the characteristic polynomial of B. Yeah. So this the game will be played on the eigenvalues of the B and A. Then we will get the answer. So my trace of A is what? This is 10. And my date of A is what? That is 5 into 5, 25 minus of minus 3, that will be 9. So it is 16. So our characteristic equation of A, that means CH of A is equals to what? This is, we can find also this from this thing. So this is my, yeah, 5 minus lambda minus 3 5 minus lambda and all, and otherwise we can write it by this manner: lambda square minus trace of this lambda plus our determinant, which is equals to 0. So we can write it as this. The middle term factor you know from your early stages of mathematics. Yeah. So the eigenvalues of A are lambda is equal to 2 and 8. Okay, now the eigenvalues of B will be the square root of that. So our lambda B will be equals to square root of 2 and square root of 8. So that is our 2 and 2 root. Okay. Now we got that as our B is, our del B is greater than equals to 0. Yeah. Then both cases can happen. Then the pair of eigenvalues will be this and also this. But these things will not occur, and also this will not occur. Okay, only these two will satisfy the conditions. As our date of B is greater than equals to 0, and we know that the date determinant is equals to the product of the eigenvalues. So 2 root 2 and 2 root 2, the product will be my 4, and the minus 2 root 2 and minus 2 root 2, the product will also be 4, otherwise the product will be minus 4. So they are not required in our case. So now we have to find the characteristic polynomial of B. Again, we are using the fact that our trace of A can be both root 2 plus 2 root 2, and our trace of A can be minus root 2 comma minus 2 root 2. Okay, and our determinant of A in the both case will be 4. That means it will 2 into root 2 and root 2, it will be 2 and 2 cross 2, which is equals to 4. Yeah. So for this case, the characteristic equation will be our lambda square minus root 2 plus 2 root 2 lambda plus 4 is equals to 0. That is lambda square minus 3 root 2 lambda plus 4 is equals to 0. And again, for this case, we will get the equation as lambda square minus root 2 minus 2 root 2 lambda plus 4. Then what will happen? Then our lambda square is now plus 3 root 2 lambda plus 4 is equals to 0. Yeah, these two will be the characteristic equation from what we get from this thing. Yeah, again I have mistaken one thing. For the real symmetric non-negative definite, this thing will also cancel out because my lambda b's are this greater than equals to 0. Okay, pardon me. This is also my mistake. So this thing will cancel out. So this is my correct answer. I am gonna write it again for your uh, easy to see that this is my characteristic equation of B. Okay. Thank you guys.